One thing we can consider with regards to integrals and ideas is how to make sense of the area of a certain curve. So let's say we have some function whose graph looks like this on some range, and we'll say we're looking at this from the x values of 0, and here it's 3, and here it's 4, just for argument's sake. When we're talking about area under the curve, what we mean is area of the curve from the curve to the x-axis. So on the interval of 0 to 3, we're talking about this region here, and I'm leaving this white space in the middle intentionally to write something in later. And when we're talking about the interval from 3 to 4, we're talking about this area between the curve and the x-axis. Right, so area under the curve, in a sense, is really the area between the curve and the x-axis. Now, one issue that comes up that is important that you are thinking about is that area itself is always a positive measurement. Right? And this is true and should make sense, just like length. Length is positive and distance is positive. But numerically, whenever the curve is below the x-axis, the numerical calculation of this space will be negative. And whenever the curve is above the x-axis, then the numerical calculation or the algebraic calculation of the area will be positive. Now let's say that this curve is some function. We'll just say it's f of x for argument's sake. In order to calculate the area, the space from 0 to 3, if you were to take the integral from 0 to 3 of f of x, right, what you're finding is the value of this space. And because the space is below the x-axis, the number you get here will be a negative number. So right now we're talking about what this means in terms of area. In terms of area, then, if that's what you want, you have to recognize because it's below the x-axis, you want the opposite of the value. Because if you were to just take the integral in order to compute the area, you're going to get a negative value, because that's what it means. It's related to the idea of change as opposed to area. But right now we're thinking about it in terms of area. If you were to integrate this function from 3 to 4, you will get a positive value. And the reason you'll get a positive value is because it is above the x-axis. So what does this mean? What this means is, if I wanted to find the area, and that's still the issue right now, is we're talking about the area under the curve, and what I mean by that is the distance between the space, the stuff in red, right, all of it. Right, so if I want to know all of this and all of that in terms of area, then I can do it a couple different ways. Right, one way, since area must be positive, is I could take the integral from 0 to 4 of the absolute value of f of x dx. Because if I'll take the absolute value of it, what that would mean graphically is now my curve will look roughly something like this, right? From 0 to 3, its absolute value would be positive. It will cause a reflection of that space. And then from 3 to 4, there will be no change. And so graphically, this is what you're considering when you take the absolute value of f of x. And so your answer will have the appropriate sign, right? You will have a positive result. The other option, which is the way I think about it, but there's nothing fancy about it, I just personally tend to approach it this way, is I'm going to take the opposite, or the negative integral from 0 to 3, f of x dx. That will cause my negative value that I get from this integral to become positive in terms of area, plus the integral from 3 to 4, f of x dx. Either one of these options will work. You just have to recognize numerically what will happen and what needs to happen to answer the question regarding area. So that's the idea about it, and we'll look at applying both of these methods in another video.